You run the same coding job through Grok and DeepSeek, and one bill is 35 times bigger than the other. That gap doesn't care how good your code is. Grok is built for speed and raw capability. DeepSeek is built to keep your costs alive, and the decision is which one do you actually pay for. Test 1, cost per token. So here's a real scenario. You're running a coding agent that fires 1 million output tokens a day, which isn't even that heavy for a production pipeline. At $15 per million output tokens, that's $450 a month just on one model. And that number compounds fast when you're iterating, so it's the kind of thing that can kill a side project before it ever ships. I pulled the community-reported API pricing for both, and the gap is pretty wild. Grok comes in at $15 per million output tokens, and DeepSeek v3.2 is 0.42, which is a completely different cost structure, not a rounding difference. On input tokens, it's the same story. Grok at $3 per million, DeepSeek at 0.28. These are community-reported numbers, so treat them directionally. But the gap is so wide, it doesn't matter if they're off by 20%. DeepSeek takes cost, and the margin is enormous. 35 times cheaper per million output tokens is the number that decides the whole comparison for most people building on an API budget. DeepSeek goes up 1-0 on the board. I know that cost gap because I've been living inside these APIs long enough to watch a billing dashboard turn ugly in real time. And if a token bill has ever blindsided you mid-project, you already know exactly what I'm talking about. Test 2, coding benchmark performance. Okay, so the objection I hear all the time is, DeepSeek is cheaper, sure, but does it actually write good code? Because if the model gets the logic wrong and you spend 2 hours debugging a function, it hallucinated. The cheap token price means nothing. Human eval and SWE bench verified are the two benchmarks that actually measure real coding ability. So let's see where both land. I had to run through the numbers twice because of how tight this was. On human eval, Grok scores 92.7% and DeepSeek scores 91.4%. So you're looking at a 1.3 point gap. And on SWE bench verified, Grok leads 79.8% to 77.2%, a 2.6 point margin. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. These are community-reported scores, so take the exact figures as directional, but the direction is consistent. Grok edges ahead on both, and the gap is real but genuinely thin. Grok takes coding benchmarks, winning both human eval and SWE bench verified, though the margin is smaller than I expected given the price difference. That ties the board at 1 each. Test 3, generation speed. The number here is 250 tokens per second, which is Grok's community-reported max. Now think about what that means in an agentic loop where your model is writing code, checking its own output, and iterating, because every second of wait time in that loop is dead time for you and your user. And if the model is slow, the whole workflow feels broken, and you start second-guessing whether the tool is even worth the cost savings. Watch what happens when you put the numbers side by side. Grok runs at 250 tokens per second, DeepSeek runs at 60, and that's more than 4 times faster. So in a real-time coding session, where you're waiting on completions, that difference is the difference between a tool that feels snappy and one that feels like it's thinking too hard. Both figures are community reported, so real-world results will vary by load, but the ratio is consistent across reports. Grok wins speed by a wide margin. 4 times faster generation is a real workflow advantage for interactive coding, not a spec sheet number. Grok goes up 2-1. So right now, Grok is ahead on the board, but context window and deployment flexibility are still on the table. And one of them is going to matter a lot depending on whether you're running API calls or self-hosting. so you really want to see where this lands before you pick a default. Test 4, context window and max output. So the failure mode here is pretty concrete. You're feeding a model a full codebase, maybe 80,000 tokens of files, plus a long conversation history, and the model just cuts you off or starts forgetting earlier context, so you lose the thread of the whole job. Or you ask for a long generated output, a full module or a detailed spec, and the model hits its output cap and stops halfway through. I didn't expect the output gap to be this wide. Grok supports a 256K context window versus DeepSeek's 128K, so double the context, but the max output difference is where it gets really interesting. Grok can output 32K tokens per response, and DeepSeek caps at 8K, which is a 4x gap on output alone. These are community-reported specs, but if you're generating long files or multi-part code, that 8K ceiling on DeepSeek is a real constraint you'll hit. Grok takes context and output limits cleanly, doubling the context window and quadrupling the max output in a single test, which is a bigger practical gap than the benchmark scores suggested. That puts Grok ahead 3-1. Test 5, deployment and modality. So there's a cost consequence here that doesn't show up in the per token price at all. You're building a product that handles sensitive data and you can't send it to a third-party API, or your usage is high enough that self-hosting actually gets cheaper than paying per call. And at that point, whether the model weights are open or closed is the whole decision. And it's a binary one. When I looked at availability, the split is pretty clear. DeepSeek v3.2 is open weight on Hugging Face, so you can self-host it, fine-tune it, and keep your data fully on-premise, while Grok 4.1 is closed API only, no weights, no self-hosting option. Grok does have native X platform integration, which is a real advantage if your workflow lives there. But for anyone who needs data control or wants to run inference on their own hardware, that closed API is a hard wall. DeepSeek takes deployment, and the open weight access is a bigger deal than I thought going in, because who controls the model matters just as much as what you pay per token. That closes it out at Grok 3, DeepSeek 2. Alright, so where does Grok win clearly? Generation speed, 250 tokens per second versus 60, more than 4 times faster, which is huge for interactive coding sessions. Context window, 256K versus 128K, and max output, 32K versus 8K, so Grok handles big jobs without cutting you off. And on the coding benchmarks, Grok leads both Human Evil and SWE Bench verified. Now, where does DeepSeek win clearly? Cost, and it's a blowout. At 0.42 per million output tokens versus $15, you're looking at 35 times cheaper on output. And for high-volume API usage, that gap is the entire business case. DeepSeek is also open weight on Hugging Face, meaning you can self-host it, fine-tune it, and run it with full data control, which Grok simply can't offer. If the API bill matters, pick DeepSeek. That 35x output cost gap is the only number you need. If you're doing real-time interactive coding and need the speed and context headroom, Grok is worth every cent of that premium. One thing the docs don't spell out, DeepSeek's 8K max output cap is a hard truncation, so if you're generating a file longer than 8,000 tokens, the response stops mid-code with no warning, no continuation prompt, and no error, and you only find out when you try to run the output and it's missing a closing bracket. So if the DeepSeek cost story got you interested, you'll want to watch my GLM versus DeepSeek comparison next, because GLM is another low-cost, open model that challenges DeepSeek directly, and the results are pretty interesting. That video is up right now.